Okay, today we are doing 7-3. This is special products of binomials. We're working out of the Big Ideas book. Please make sure and write down the problems. For page 375, I switched it from the board. Page number 1 through 24 all. Then you're doing 25, 31, 32, 34, 39, 42. All right, so when we are looking at special products of binomials, we're going to double distribute and first see what this looks like. Liam, when I double distribute this, what do I get? X times X is?
X squared.
Keep going.
And you get 3x.
What kind of 3x?
Negative 3x.
Negative 3x. And?
Then you get 3x, positive 3x. And then you get negative 9.
Okay. And when we combine like terms, what do we get?
X squared minus 9.
Good. Well, notice with these type of binomials, my inner products are getting canceled. So let's look at the next one, number 2. Mark.
Y squared plus negative y7.
Negative 7y.
Negative 7y plus 7y minus 49.
And again, when I combine like terms, Mark, what do I get?
You get y to the second power minus 49.
Okay. So are we noticing a pattern here? Yes, Ani, can you explain it?
It's always the 2 in the middle that get canceled out.
And when does that happen? When does that happen? Brett?
In the binomial, when the second number is the same and opposite.
Right, when the constant term is opposite. When the binomials are exactly the same and the sign is opposite. That's when this will happen. And we call this a difference of squares. Now, this isn't called a difference of squares. The result is. Why is it called that? Because it's a perfect square minus a perfect square is what your result ends up being. So what would this be without doing the middle part? What would we get? Jared?
M squared minus 16.
Perfect. M squared minus 16. And the next one, Shia?
You would get t squared is minus 25.
Good. Okay. All right, now let's look at the actual pattern. So a lot of times they'll use A and B when they're talking about the pattern. When you see standardized tests, you'll see it in terms of A and B or an X and Y. So we know that what happens, we square the first term. We know that we square the second term, but that when I go A times negative B is negative AB, and B times A is positive AB, that they cancel each other out. And so what we have is a perfect square minus a perfect square. That's why we call it a difference of squares. Everybody say a difference of squares.
Difference of squares.
All right? So what would number 1 be, please? Somebody different. Ben Ginsberg.
P squared of minus 64.
Good. Next one, number 2. Josh.
Y squared minus 144.
Y squared minus 144. Dean.
M squared minus 36.
Perfect. Questions? All right. So let's do one more together. I'm going to write the formula up here. Remember, it's going to become A squared minus B squared. Let's just write this. A plus B times A minus B is equal to A squared minus B squared, a difference of squares. So what would number 1 be, please? Brandon?
B squared minus 4.
Perfect. Okay. Let's jump down to number 4. Jump down to number 4. Colin.
Would that be... Oh, wait.
Which one's my A?
Sorry, I was looking at number 5.
Okay,
Your A is 2B.
Okay, so
Then it would be 4P squared
4p squared minus 9. Because I would have positive 6p and negative 6p, and they would cancel each other out. All right, you guys pause the recording and finish the rest on your own. About to record. All right, now check your answers. Number 2, x squared minus 81. Number 3, w squared minus 100. Number 4, 4p squared minus 9. Make sure on number 5 you keep it in order, like we have the 6 first, so keep it that way. It didn't ask us to put it into combined form. Okay, we get 36 minus t squared. Number 6, n squared minus 25. Next one, Yali. Good. Next one, please. Fareed.
16 minus q squared.
16 minus q squared. Good. Next one. How about Arun?
64
Good. Good. 64d squared minus 1. And Griffin, the last one?
4 minus 25g squared.
Perfect. You get the idea? I want to introduce something right now that I was actually doing at the end, but I'll kind of bring it up. In the book, under example number 3, there's a problem that looks like this, and we can use 26 times 34. Now, they use this same idea, Elijah, to multiply these numbers. So we can break 26 down to 30 minus 4, and we can break 34, multiply, same thing, right, to 30 plus 4. What do we call that? What? A difference of squares. Isn't the same term the same? Just like when I have a plus b, a minus b. Isn't it the same thing? It's only we're using this with numbers. So then what we can say is we can go backwards and say 30 is squared, and we have minus 4 squared, right? We know that the inner and outer terms will cancel. If I were to write this out, it would be, and double distribute, I would get plus 30 times 4. Oops. And then I would have minus 30, minus 4 times 30. Isn't that the same thing? Right? And then I have my minus 4 times 4. But these are going to both be plus 120 and minus 120. Don't they cancel out? So we don't need to write those. Minus 4 squared. You with me? Okay, so you will be doing this for homework. I have 900 minus 16, which is 884. So we're using our difference of squares to multiply out numbers. You should have this example. Okay? So if I had something like, let's say I had 27 times 33. I could say this is 30 minus 3 and 30 plus 3. So this would be 30 squared minus 3 squared, which is 900 minus 9. So wouldn't that be 891? Got it? Questions? All right. Let's move on to our next rule, which is binomial squares. Now, this seems to be the hardest one for some reason for people to grasp. All right, what does this really mean? Ani?
It means that x plus 5 times x plus 5.
The quantity of x plus 5 times the quantity of x plus 5. Remember, we're not distributing exponents. So this really means x plus 5 times x plus 5. So when I double distribute, okay, we get x squared, right? If I distribute the next one, what am I going to get? Jared, Josh,
5 plus 5x.
plus 5x. And then when I distribute here, I get another 5x. And when I distribute here, I get plus 25. And all together, that makes what? Elijah?
X squared plus 10x plus 1.
Perfect. Okay. Now, if I were going to make a formula out of this, let's call x a and b and 5 b. This is a plus b, and we're squaring, right? So, what would this term be called? X squared. What would x squared be called? How am I getting that? Sophia. A squared. What is the last term going to be called? Tristan?
B squared.
B squared. Now, how am I going to write that middle term? Notice. Brandon?
Would it be 2AB?
Yes. Here's A, B, plus A, B. It's 1, so can't we just say it's 2 times plus 2 times AB? I don't even need the parenthesis. 2AB. Now, do you understand why it's 2AB? It's because when I do my distributing here, and I get plus 5x for that, and I do my distributing here, and I get plus 5x here, there's 2 inner and outer terms. Are we clear on that? So, that's going to be the formula that we are going to use with these special binomials. So, notice, if I square the first term, I get this. If I square the last term, I get this. If I multiply AB together and then double it times 2, how I get that middle term is I multiply them together and then multiply it by 2, and I get my middle term. Is that making sense? So let's try that. Here's our binomial. Make sure you have that binomial square pattern down. Did you write that?
Nope.
Okay, so what am I going to do to get my first term for number 1? Dean.
So it's going to be P plus
Hold on. The first term.
oh,
I just want the first term right here.
P squared.
P squared. Okay? What's the you want to go right for the last term? Because that's easy. What's the last term, everybody? 81. Now, how do I get that middle term? Shayna?
Multiply 9 and P
And that becomes?
9P
And then?
times 2.
Times 2, double it. And that becomes? 18. 18p. Questions? Yes.
Or can you just add the 9 to itself and then add the 2?
I'm trying to give you a quick way to get the middle term. It's the same thing what you just said. Okay, multiplying the 2 middle terms together, the P and the 9 together, the A and the B together, double it. I just want you to be able to recognize this formula here. Okay? Okay, what am I doing for the next one, number 2? Sam.
Okay, y squared
Uh-huh.
plus 144.
No.
Oh.
Now, how am I getting that? Look up here.
It's negative y. No, negative 12y. So it's negative 24y
Perfect. Plus negative 24y. Good. Negative 24y.
plus 144.
Right. And you will notice, especially when you have these subtraction, you're going to have the same signs every time. Griffin, next one.
It's going to be m squared
Uh-huh.
plus 12m
Plus 12m.
yeah.
minus 6m and minus times 2. Or minus 6m and minus 6m make,
Oh, minus 12.
right. And keep,
Plus 36.
yep. Okay. And then the last one, Elijah?
X squared plus 6x plus 9.
Good. Now, when we factor, factoring is really just starting, is just starting with these answers here, and you guys have to tell me the factors. When we start factoring, we're going to start with the trinomials, and you're going to tell me what times itself equals this. That's what factoring is. All right, so now I'm going to write down the formula on the top, and we're going to do 1 through, so it's a squared plus 2ab plus b squared. Okay, let's do the first couple together. What's the first one going to be? Arun?
T squared plus
Remember, every time, this is your A, this is your B, and this is how you get the middle term. 2t. Keep going. Good. Next one, Griffin.
It's going to be x squared
Mm-hmm.
plus 6t.
Here's my A, here's my B. When you
6x.
what is it?
6x.
What kind?
Plus 6x.
Okay,
Or
minus 6x.
and then it's going to be plus 1.
Good. Next one, Griffin.
N squared
Mm-hmm.
minus 22
Perfect.
plus 100.
Good. You guys finish it up. It's no different. Well, let's try number 4. Number 4, Liam. First term. No, the whole thing. What?
Is it 4p squared?
4p squared. Square the first one. Square the last one. That's the easiest. What is it?
Plus 14p.
Okay, I said the last term is the easiest to get. There's 3 terms in this. What's my last one going to be over here?
49.
49. Now, the hardest one to get is the middle term. So every time, what have I done? If this is my A and this is my B.
14p plus 14p.
Which is?
Positive 14p.
14p plus 14p makes positive 14p? You're not hearing yourself. You're saying that it's 14p plus 14p. What does that make? 14 apples plus 14 apples make how many apples?
28.
Okay, plus 28p. That's what it is. Do you understand? You're multiplying them together and multiplying it by 2 for the inner and outer. Okay, you guys go finish the rest. All right, let's get rid of this, my writing. And what did you get for number 5, please? Somebody I haven't heard from, Billy Fisher.
36.
Woo, number 5?
Oh, wait, no, wrong one. 25p squared plus 90p plus 89.
Perfect. Questions? Okay, number 6, please. Colin Ellman.
I got 16x squared minus 24x plus 9.
Perfect. Good. Plus 9. Next one, Julian Willoughby.
x squared minus 2xy minus y squared.
Pretty much the same as the formula, right? Ben Ginsberg.
Number 8. Minus 4x squared.
Number 8. Now, okay. Keep it in the order. I'm asking you to keep it in the order. What's the first term?
10x.
No?
Wait. 25 plus 10x minus 4x squared.
Okay. Nope. Okay, one more time. The first term. Look up here. First term, Ben.
20 is 25.
Okay, last term. Is it negative?
4x squared, sorry.
Right, because negative times negative makes a positive. Now, how do I get my middle term?
You have to do the 5.
We don't do, we add, subtract, multiply, or divide.
Add 5.
No. We don't add 5. Did you not get the pattern that we were talking about? Were you doing it your own way the whole time? That's why I taught you the pattern to like make it go a little bit quicker. So I said if this is our A and this is our B, remember the formula is this, Ben.
Oh, it's
2AB.
2AB.
So how do I get my middle term? We said 25. Okay, so what am I doing? 25. How are you getting 25 times 2? One more time. The formula is A squared plus 2AB plus B squared. If this is A plus B, right? Squared.
So it would be negative 10x.
Negative.
10x.
What about this? We know that A is this, B is this, multiplying negative 10x times 2 is
20x.
minus 20x. And then the last term is going to be plus
Plus 4x squared.
Good. Okay. Next one, number 9. Shh. Number 9. Nico.
9b squared plus 12b plus 4.
Good. Last one, number 10, Adriana.
64 minus 3k plus 4.
3K. Not 3K.
Oh, 32k
32K.
plus 4k squared.
Okay. Now, one more time, when I do this with numbers, okay? When I do this with, do not put it away. Okay, let's just do this one right here. Okay, if I have 29 squared, I can also use this binomial products to break this down to 20 plus 9 times 20 plus 9. And remember, if this is A plus B, my A squared would be 20 squared plus 2 times A times B, 20 times 9 plus 9 squared. So what does that equal? 400 plus 360 plus 81. That's 760 plus 81 is 114, 841. Is that right? Does that make sense? No or yes? I broke down 29. Hold on. Not dismissed. I broke down 29 to 20 plus 9. 20 plus 9.
2 times 20.
All right, that's the end of the lesson.